Welcome students. Today we are going to discuss about one of the linear data structure called stack. Stack is a example for linear data structure wherein in linear data structure we are accessing the element one after another, which can be implemented by using array or linked list. It is also called as restricted list. It is a ordered group of homogeneous item of elements. We can store a set of elements of same type in restricted way by using stack. It follows the principle called last in, first out. It means that we are assessing the element which is inserted recently in the list. That is, recently pushed data or inserted element are popped out from the stack or deleted from the stack. That is, last element to be added is the first to be removed. It is called LIFO. It is also called as philo. Philo means first in, last out. First inserted element are popped out last. Elements are added to and removed from the top of the stack because it has only one end. Some real world example or object which resemble stacks are a stack of trays. So we can't uh, select tray or take tray in between. If we wish to select or take middle of the tray means we have to take top of the tray and we can take middle trays. So we can access or take top of the plate only. In similar way, stack of coins, example for stack. Then stack of shoe boxes in shop, example for. So these are the object which resemble stack concept, and the stack of neatly folded sets. For example, real world example which resembles stack. It is used in many areas. There are some objects which you see already in the real world. Back option in the browser or forward option in the browser, and undo option in Office automation tool. If you click undo means it goes to previous stage. So the previous stage pointers are stored in the memory. If you wish to go to previous stage means this recent stage means it can be implemented by using stack. So this is the real-time example. There are several operations which is pertaining to stack ADT. So I already told ADT is a abstract data type which has data and operation. Here data are maybe an integer or collection of characters or a collection of strings, etc. And operations pertaining to stack ADTs are push for inserting the element into the top of the stack, pop used to delete the recently stored element, peek or top is used to retrieve the recently stored data which is available in the top of the stack, and is empty operation, it checks whether the stack is empty or not. If it is empty, it returns true, otherwise it returns false. We can, in other way, we can say that if the stack is empty, it returns 1 or it returns 0. Useful operations to check whether the stack is full or not. Here I start a stack operation called a push. The push functions adds new element onto the top of the stack. The preconditions that should be hold before inserting the element is the stack has been initialized and it's not be full. The force condition, that is after inserting the element, the new element should be available in the top of the stack. That is force condition. Here animation which resembles stack push operations are. Here I have three elements. Consider stack is empty. One by one I am inserting the element. Here you have only one end, top end, that you are inserting the element. This is the animation for push operation. We have only one end. We can't insert the element at middle end, or we can't insert the element at the back end. We have only one end, that is top end. This is the implementation for push operation. Here I am going to implement stack operations by using array. Before inserting the element, we need to decide what kind of data I am going to store. Here I am going to store integer value, one integer value. One by one I am going to insert the value, and after inserting it may not return any value, so I use void. For inserting the integer element, I should pass the argument. Here push is the operation name. Before inserting the element, we need to check whether the stack is full or not. Okay, when stack is full, it reaches the maximum size. Since array index starting from 0, we can check the stack full condition as size minus 1. If array index starting from 1 means, we can check whether the top position is equal to size. Now, in most of these programming languages, the array index always starting from 0. So we need to check the top pointer is equal to size minus 1. Size means maximum size of an array. Top means pointer which points to recently stored data. For example, I have an array. This is the memory block for an array. Initially, I don't have any element in the stack. Actually, we maintain one pointer called top pointer. Top pointer. This is used to point to the recently stored data index. Here, array index starting from 0 to 1. This is the index reference. This is the array value reference. Array index always starting from 0, 1, 2, 3, 4. Here the size of an array is 5. So when it reaches 4, that is generally I can say size minus 1, we can say that the stack is full. Initially, no element is available in the data. If one element is available in the data means the top pointer points to 0. Hence, the initial value for top value may be set as minus 1. It means that it points to nothing. There is no element in the stack means I can set top value equal to minus 1. When I try to insert the value means we need to increment the top value by 1. For the purpose, I use top equal to top plus 1. When I set this, top value set to 0. From minus 1, it leads to 0. So the top position here, array of top position, I can store the value x. For example, if x is 10 means I can set. So for inserting the element, I need to increment the top value by 1 and I need to set the expression as array of top equal to 10. Generally, I can say x. Here I use stored 10. Now, top points to top points to 0. Okay. When I insert element 10, top will be 0. The second operation, again I am going to insert 20. If I insert 20 means, again I need to execute these operations. Same operation. Now, top will become 1 and I store data 20. 20 is stored. Automatically, top pointer incremented by 1 locates the recently stored data. So, top pointer is used to denote the or point out the recently stored data syntax. It is not a programming pointer, it is a pointer which points to the recently stored data syntax. Okay. If I wish to delete the element means just simply decrement the top counter. That's all. Initially it was 1. Now I am just pointing to 0. Now automatically when I set top equal to top minus 1, top counter will be set as 0. When I wish to insert the element means use the expression top equal to top plus 1 and use the expression array of top equal to required value. The data type is stored. When I wish to delete the element means just decrement the counter, top counter by using the expression top equal to top minus 1. That's all. Simple program. Here. Before inserting the element, I need to check whether the stack is full. If it is full means just to say stack overflow. So we can't able to store the data. So just say stack overflow. Otherwise, increment in the count top value, top index, which is used to refer the recently stored data and store the data into the stack at the topmost position by using the expression called stack of top equal to x. Here I have used array as a variable. Here I used stack as a variable. Okay, that's all. For deleting the element, I told already just to decrement the counter by 1. Before deleting the element, we need to check whether the stack is empty or not. We can't delete the element at the empty stack. We are not having the data. Then how do you delete? So before deleting it, you have to check the top pointer is -1. Top pointer is -1 means it means that no value available in the stack. For popping the element, we need to check whether stack is not empty. That is precondition. Post condition is the top element has been removed from the stack and we can keep the deleted element into the variable by using temporary variable. This is demonstration for deleting the element. See here, initially we have 5 elements, which is ranging from 0 to 4. When I remove the element, the top pointer will be decremented by. We are maintaining only one pointer. That's all. It is in programmatically I can say top equal to top minus 1. That's all. Before deleting the element, check whether the stack is empty. When top equal to 0 means, it means that we have only one element in the stack. If stack top value is equal to -1 means, it means that we are having no element in the stack. So if top equal to -1, just print stack underflow, immediately it returns. Otherwise, it just retrieve the top of the stack and store into the temporary variable and decrementing the value by 1 to remove the element from the stack. Finally, it returns the deleted element, okay, which is available in the item variable. Okay, next. This is the push and pop animation. You push the element, top value will be incremented. You pop the element, top value will be incremented. This is another illustration. Initially, top points to -1. We have no element in the stack. When I push value 2, the top value points to 0, storing the data. When I push value 3, the top value incremented by 1, now pointing to 1, and we have data like this. When I push value 5, the top value automatically incremented. It is pointing to say, index 2. When I pop the element, it just decrementing the top value by 1 and then pointing to the second data. When I click give pop function again, means automatically the top value will be incremented by 1. After that, when I push value 10, the top value incremented by 1. This is simple illustration which resembles peak or top operation used to retrieve the top of the element. Before retrieving the top of the element, you need to check whether the stack is empty or not. We can't apply peak operation in empty stack. Just check top equal to -1. If it is empty, it just returns. Otherwise, it will return the top of the stack. Top of the stack is available in the stack of top position because top is index points to the recently stored data. Stack is an array which holds the elements of the stack. To check that stack is overflow or stack is full by using the function isFull. If top equal to size -1 means it returns 1, otherwise it returns 0. Here, this function which accepts no argument and it returns integer. In a similar way, to check the stack is empty or not by using the isEmpty function which accepts no argument and returns integer. So to check stack is empty, if top value or top index is equal to -1 means it returns 1, otherwise it returns 0. The applications of stack are regression. In regression, we use stack ADT to store the recently called function, and we use stack concept for evaluating expression. In a compiler design, we have one module for expression evaluation. Actually, we have some infix expression, programming expression, which may be converted into postfix as prefix. This will be useful for a compiler to evaluate easily without considering about the precedence, operator precedence. In compiler design, we use expression evaluation, which makes use of stack. And also, we can convert expression into prefix or postfix by using the stack concept. Finally, parsing is used to extract the tokens which is available in the expressions, array symbols, collection of symbols by using stack concept. For example, we have a XML document. XML means extensible markup language, which has some format, specified format. We can validate the XML document by using the stack concept, whether the tags are correctly enclosed or properly nested or not. These things can be validated by using the stack concept. So in parsing also, we are using stack concept. These things will be discussed in future. I used to discuss some problems we asked in day 0 company or day 1 company. Okay, first problem is program to reverse it. You can reverse the string by using the stack. It is a Simple operation. Before that, I need to show the demonstration how to implement stack ADT. I have header file and I am going to store collection of integer. So just use stack of 10. You can set maximum size of a stack equal to 5. You need to have a pointer, top pointer, which is initially set as -1. Here I use push operation, implement push operation. Push by the push. I am going to insert integer element in the array, stack array. Top equal to -1. Say overflow. Else just increment in the top value by 1, plus 1. Then stack of top equal to X. That's all for the push function. For pop, you have to check the top equal to size -1, not -1. For push operation, next implement the pop operation. For pop, I return the deleted element, which is deleted recently, which has no argument. Just check tag stack is empty. If it is empty means just mention underflow. Just mention top equal to top -1. I need to keep track of the deleted element now, so I just use return as a variable. Just store recently deleted element item equal to stack of top. Here just return recently deleted element. So I implement the top push and pop. I'm going to retrieve the top of the element. Just use peak. Same thing, but don't decrement it. Here now we are going to retrieve the element, not deleting. So just disable this. Inside the main function and just check. Have sizes. Have a loop. Infinite loop. Get the sizes. Get the sizes by using scanf statement. This is the comma ampersand size. Have switch case to call push and pass of operation. Case 1 means they are going to push the element. Enter element to push. get the element here we can declare value variable. After getting the element from the user, just call this function and pass the value which is retrieved from the user. Then give break. That's right. Next for pop operation. Just say element deleted and print the deleted element is D, comma pop. Just call pop. Say the preference we can call to break. We give case 3. Say in front of function, just say top element is give call fee function. That's in case 4, just it means that you are going to exit the environment. Call exit function to come out of the program. Here you have a default option to tell you have entered invalid size. This is the concept behind the event-driven program. You can print the element which is in the stack by using void display function. Still use a loop I equal to 0, I less than or equal to top I plus plus. Print the available percentage %d slash use stack of slash n here in the new line. You can call display function here. Have hash 4 here, just call display function. That's not. We have done. Now to include header file as info std libdot h. I think so. Because the state function is available in the std libdot h. Save the file. Give 1 means the element first. Now you can call for to display the stack. I have 10 in the top of the stack. Now again break here, then use break here. Okay. Now it will work. Here I use 1, insert 10, and display the value 10. Again I insert 1, I insert 20, then enter the size 4. I have two values. Again I insert 1, inserting the value 30, checking the stack. I have 3 elements. When I call pop, that is size 2 means it will delete 30. It should delete 30 because recently inserted element is 30. See here, element is there. The deleted element is 30. See here. Now I click 4 to check the stack. So recently deleted inserted element only deleting. Okay. And also I can call top to retrieve the top of the element. The top of the here the top of the element is 20. The top of the element. Okay. I wish to check overflow condition. For example, I am calling 1, I'm inserting 30, now checking 4. I have 3 elements. My maximum size of the stack is 5. Again, I'm trying to insert 40. Again, times to inserting the value 50. Checking. I have 5 elements. Okay. Again, I am trying to insert the element. Just check. Entering 60. It is telling overflow. So when a stack size reaches maximum size of the stack, say overflow. Now I keep on deleting the element. Finally, at a particular point of time, it will say underflow. For the I keep on deleting the element. 50 is deleted, 40 is deleted, 30 is deleted, 20 is deleted, 10 is deleted. Finally, it is saying underflow. That's all. Now I am getting out of the program. So in this way, we can implement simple implementation. Here we have array to implement the stack array, and we are maintaining top pointer. And just inserting the element by using 2 keywords. These are the important keywords. Important keyword. Please understand. 2 keyword are important. Before that, we are checking the overflow. Here, this one is an important keyword. See here, this one is important keyword. Before that, we are just checking underflow. Peak also, we have one important condition. That is, we are storing the getting the data which is available in the stack and storing the variable. We are not using top equal top minus 1 while retrieving the data. In display function, we just use loop 2, which is ranging from 0 to top and printing the elements which are available in the stack. This is a main program, which makes use of switch case to demonstrate stack operation. Okay. Now I am going to reverse the string. We have one copy of this stack reverse. Okay, because we are reversing the string means reversing the set of characters. So your stack should be character array. Okay, we are going to store the stack set of characters in a stack. So just have same thing. Copying the element also. We are retrieving the character. Okay. Here also we need to use character. Here don't use main program at all for reversing this. Just get the input from the user in terms of array. Input, declare the variable, array variable, get the string percentage. Yes. Here I will store the each and every character in the stack. I less than str len of I plus plus. Just pushing the element to the stack. Push the element. Try to push the element character by character. Include a string.h. Expand the stack size because I am keeping track of this. When I store the element in the stack, for example, when I give hello means hello say string means automatically stack contains the value first which will be stored, then E will be stored, L will be stored, followed by L will be stored, then O will be stored. In this way, stack contains values. Okay. When I call this push operation, the stack contains like this. Stack array contains values like this. Stack available in the bottom of the stack, followed by E, L, followed by L. Finally, O will be stored. After pushing the value, I am just popping the element which is available in the stack until the stack is empty. This can be checked top not equal to -1. I am just popping the element and printing the data. See here, popping the element by calling the pop function and printing the same, because pop function returns a character no, which directly printed by using printf statement. That's all. Then automatically first 0 printed, then L printed, and so on. Finally, you will get value like O, L, L, E, H. So by using stack, we can reverse the characters in the string by using these operations. Here I have implemented stack for this. In C++, we have inbuilt function. Java also we are having. I am in a position to declare the variable in there. Here when I give hello, it will give reverse. You can reverse the string by using it. Okay. By using this, I can solve another kind of problem. Next problem is program to check the string is palindrome or not. See here, checking the string is palindrome. I can use these operations. I have implemented a stack which makes use of characters. Here I am checking. Just retrieve. Just get the input from the user and push the element to the stack. Now use the same for loop. Same for loop. It is for loop and all. You can use while loop. Here, just check. Just have I equal to 0 here. Just the values that you access. For example, you have values in array. No? If a of I equal to pop element. If a of I equal to pop element. For example, you have input level. Level is a palindrome string, and you have elements, and you are storing the data in the top of this. We are storing the data in the stack. How will you store? First you store L and E followed by B followed by E and L. Now you are reading the first character on the top of the stack and comparing. If it is equal means no problem. And reading the second character and checking the top of the stack, both are equal, just ignore it. If it is not equal means you can say that it is not boolean row. Just check. If it is not equal means just say that not boolean row. Okay. Immediately return when all the characters are matched with the values that you read and the top of the stack is matched means no problem will occur. After some point of time the stack will get empty. When stack gets empty means it will come out of the while loop. Now you can say it is a boolean row. It's not equal, it will say it's a boolean. It's not a boolean row and will return if first character last character match and second character last character which is before last match and so on means it will never enter into the if condition. It means that it's a boolean row string. Okay. Just check. Just give check it's not boolean row. When I give level also the same. Here I need to use increment operator. I missed it. See here, you need to check each and every character in array. I need to use increment operator. Now give level. It is saying boolean row. Okay, level is boolean row string. Now give hello. The boolean row. Okay. In this way we can check whether string is boolean row or not by using stack. Very simple. That implementation, stack implementation is a template for you. The only core code is this one. Checking whether stack is, string is boolean row or not. Okay, this way we can implement it. We will see further applications in next class. Just work on this problem. Program to reverse the words. For example, when I give input like hi, how are you? This is separate words means output should be a you are how. So this is the assignment for you. Please work on this problem. We will see in the next class. Thank you.